some undesirable material like free lime and magnesia, with the presence of free lime and magnesia, we observe expansion in cement. We observe expansion in cement, and this expansion in cement is no good. It shouldn't be there. So, I should say the cement with the free lime and magnesia, it is unsound. That cement is unsound. But it should be sound, and when it is sound, when the cement is sound, when the cement is called sound cement. Now, we have to check the expansion, and we have a special apparatus for it by using Le-Chatelier's apparatus. By using the Le-Chatelier's apparatus, we can check the soundness, the expansion. Le-Chatelier test. Now, in this, if the expansion is not more than 10 mm, it is not greater than 10 mm, then the cement is okay. It is a sound cement. So, this is all regarding the soundness part. Now, coming to the third property, the setting time. It is a very general term, setting time of cement. Now, what is setting of cement? Now, when the cement is added with water, when the cement part is added with the water, what happens? It gradually becomes lesser and lesser plastic. It gradually becomes plastic with time, and a stage is obtained when the cement paste becomes rigid. When the cement paste becomes rigid, and it can withstand some pressure. Now, this cement can withstand some pressure. When you put some pressure on it, the cement can resist it. So, this stage is called setting. Now, this is the setting stage of cement. Now, we have two setting times here, the initial setting time and the final setting time. The initial setting time and the final setting time. In the case of OPC, generally for ordinary Portland cements, the initial setting time should not be less than 30 minutes. It should not be less than 30 minutes, and it should not be more, the final setting time should not be more than 10 hours. It should not be more than 10 hours. So, the slight rigidity in the cement which can withstand pressure is termed as setting. It is of two types, the initial setting and the final setting. The initial setting time should not be less than 30 minutes, and the final setting time should not be more than 10 hours. So, these are some of the physical properties of cement. We have studied in detail regarding the cement part, the first ingredient. Now, I would like to move to the second ingredient, the aggregates. The second type of ingredient, aggregates. Now, in this we will start up with fine aggregates. In journal language, we call sand as the fine aggregate. Sand is the fine aggregate. However, in sands also we have fine sand and coarse sand. We have two types of sand. So, these fine aggregates, in short we write it as Fa. These are the first type of aggregates, the fine one. Now, in concrete, these aggregates act as a filler. These aggregates act as a filler. Now, these aggregates cover 70 to 75% of the volume of concrete. The fine as well as coarse aggregate covers 70 to 75% volume of concrete. And regarding cement, cement covers 15 to 20% of area, of volume, not area, 15 to 20% of the volume of concrete. So, you can very well see how important these aggregates are. So, these aggregates decides how to make the concrete economical, because it is covering 70 to 75% volume of concrete, acting as a filler. The first one, the sands. Now, what are fine aggregates actually? The aggregates, the fine aggregates are the aggregates which are having size less than, just concentrate, the fine aggregates are the aggregates which are having size less than 4.75 mm. 4.75 mm. So, this is the basic definition of fine aggregate, and the sand should be well graded, very important. The sand should be well graded. First thing, it should be well graded. Secondly, it should be free from silt. It should be free from silt and clay particles. Now, silt and clay particles are not good if these are present in the fine aggregates, because these silty and clay particles hardens slowly and they develops poor strength. They are responsible for the poor strength of concrete. They are responsible for the poor strength of concrete. And it is very surprising that every 1% increase of silt reduces the 5% strength of concrete. You will see how important the presence of silt and clay is in the fine aggregates. Every 1% increase in the concrete reduces the 5% strength. There is a 5% strength reduction if silt is present in the concrete. So, it is better that it should not be there in the fine aggregates. Now, in Punjab, now in fine aggregates we have different zones actually. We have different zones in IS codes given 1, 2, 3, 4. We have 4 zones, and Punjab is lying in this 4 zone. Sand is falling below 4 zone, which means that sand is comparatively finer. In Punjab, the sand is finer comparatively. It is finer in Punjab. So, this type of sand produces the concrete which is cohesive. It produces the concrete which is cohesive. I am talking about the Punjab. We have cohesive and dense concrete. But in reality, it is not having the high strength. It is not having the high strength, and it consumes more cement. It consumes more cement per cubic meter. And this is a very interesting feature which you should know, since we are here in Punjab, that in Punjab the sand or the fine aggregates are comparatively finer. These are falling in the zone 4, below zone 4. So, that is why they are more cohesive and dense. They are not having very high strength. So, they consume more cement per cubic meter, which I should say it is not good. So, this is what I call about what I discussed about the fine aggregates. Now, moving to the coarse aggregates. Now, these are having the size more than 4.57 mm. Coarse aggregates are having the size more than 4.75 mm. Now, these are having two categories, coarse aggregates 1, which is between 12 mm to 20 mm, and coarse aggregate 2 category. Coarse aggregate 2 category. Now, this is falling in this range 8 mm to 12 mm, and in Punjab we are using this second category. Most of the coarse aggregates we are using, it is between 8 mm and 12 mm. Now, rounded and angular, we have two varieties here. We have two varieties of coarse aggregates, rounded and angular. Both are good. Rounded and angular aggregates are good, but we shouldn't go for the flaky ones. The flaky aggregates are never good for it. Flaky and elongated aggregates are not good. Now, the another ingredient which I should look into it, it's water. Very simple, I should say, a water which is fit for drinking can be used for the concrete. A water fit for drinking purpose, it is good for using in concretes. It should be impurity free. There shouldn't be many impurities in water which we are using for the concrete, because it adversely affects the strength of concrete. And the quantity of water, its quantity is always predetermined in concrete. The quantity is always predetermined, and any increase or decrease in the quantity, any increase or decrease in the quantity of water may give adverse results. The concrete may be porous, it may be honeycombed. So, you can see how important the quantity of water is. The quantity of water should be optimum, predetermined, whatever is decided. The last ingredient, it is the admixtures. So, what are admixtures now? What are these admixtures? Now, concrete admixtures are newly introduced ingredient. Now, these are utilized to meet specific requirements. To meet specific requirements. What does it mean? Why admixtures are used? These are basically not used for general construction purpose. We are not using these admixtures for general purpose, but these are used for special cases. Now, which are those cases? We use admixtures as an accelerator. We use admixtures as accelerator to increase the rate of strength, or to fast up or speed up the works. We use these as retarders. Admixtures are used as retarders to slow down the process. These are used as waterproofing agents. These are used as waterproofing agents. Waterproofing agents. So, these are additions. Admixtures are additionals. These are used as superplasticizers. Superplasticizers. So, you must have seen this is the fourth ingredient of concrete, the admixtures. So, this is all regarding my today's lecture of admixtures of different ingredients of concrete. I would like to just sum up what we have today seen. We have seen that what exactly is concrete, what are the different ingredients of it, the cement, its types and physical properties. Then we have seen two types of aggregates, what are fine aggregates and coarse aggregates. something regarding the water. It should be fit for drinking. That water is good for concrete purpose. And last but not the least, the admixtures which can be used as retarders, accelerators in concrete to give a good concrete. So this is all regarding my today's lecture of ingredients of concrete. Thank you very much.